Python so that you can work on your command prompt. Okay, so now once that is done, let's start with the NumPy first. But before that, we need to first of all learn what is this NumPy. So why should I learn this NumPy and what is the use of it? So basically this NumPy stands for numerical Python, and it's a wonderful concept because it's one of the type of library you'll be using with arrays, and this array concept leads to like show you like it become a like this famous that we'll be calling that as NumPy arrays instead of calling NumPy, and that's because you'll see in the next slides. And obvious, as you can see, you can easily install them using pip install library, right? So it's a open source project and it's free to use. So okay, now as said before, the main important point why I'm mentioning here is why NumPy arrays when you already have lists. I hope you have learned about lists in Python. You've been knowing about lists. So why should I import another package called NumPy and I have to import NumPy and I have to use its arrays and when both arrays and lists are of the same kind? That's because in NumPy arrays are 50 times faster than lists in Python, and its numerical computation far better and easier than lists. And that's because when you have another doubt like, so if NumPy is also installed like written in Python and lists also written in Python, and you know that Python is a less computation and less in speed execution, right? Other than C, C++, and Java, then why NumPy is preferred? That's because even though some of the parts of the NumPy are written in Python, but most of the parts like its computation and its execution was written in C and C++, and that's give the speed and the execution faster in NumPy. Okay, now let's jump into the notepad and with some of the cool features. Okay, so let's start with the basic first. So the first step you have done, right, the pip install NumPy, you have downloaded your NumPy. Now what you have to do is you are going to import that NumPy, and this NP is called as the alias name.
Sunil, your notebook is not visible.
Okay, sorry.
Just share the whole screen. Yeah, perfect.
Okay, can you see this? Okay, good. Sorry guys. Okay, this is the basic command you're going to use while you're working with NumPy, like import NumPy as NP. This NP is the alias name you'll use with NumPy. You can keep your own name, like you can keep like NUP or whatever you want. It's just an alias name. And why you prefer NP is in industry, wherever you see in resources somewhere, you'll see only NP as a command, so you're going to use that. Okay. Now let's start with the basic NumPy operations. Like this is the basic operation you'll start with NumPy. That is, we create a small array, but that is not even a single dimension, which means it's not a one dimension array or two dimensional array. It's just a normal element. And the second, I've taken the second array that's a one dimensional. I've taken like a list. You have seen this in list, but the new thing you have seen is this array. This is what I have used here using a NumPy package. So from NumPy, I've imported by taking alias name as NP. I've taken array as a new concept, and I've taken a list of one-dimensional elements. In a similar manner, I have taken two-dimensional elements. And using a NumPy, now what I'm going to do is, I'm using the cool features like n dimension, which helps me to know what kind of dimension it is. So for the first element, what I have done, it's of no array, it's no dimension. That's why it's shown in the output as 0, which means it's not even a one dimension. The second part, which is 1, 2, 3, 4, 5, it's a one dimension. So it's showed at 1. Similarly, it's a two dimension, it's showed as 2. Now you can also set your own dimensions. Like suppose I have a one dimension array 2, 4, 6, 7. Now I want to make it as 10 dimension. Then this same, but you have to take care of year and year. The thing is, here it's n dimension only, but here it is n dimensions. So that's why you have your NDMIN. It's not NDIM. It's both are different. And you'll assign it as 10. It's not on 10. You can assign whatever you want. So what I've done is I've converted from 1 dimension to 10 dimension. Okay. Like in lists or in the like you'll be using right in the strings. You can also use the concept called indexing and slicing even in NumPy as well. See. Now for the first one I have created for a 1D array, as I said, I've created using my NumPy package. I've used its function called array, and I have created one 1D array, and I've given 4 elements in it. Similarly, I have taken another one. I've taken 2D arrays. Like it consists of, what is 2D array? It's a collection of 1D arrays. So I have a collection of 2 1D arrays. So it's called a 2D array. Now 3D arrays. It's a collection of 2D arrays. Now I have 2D arrays in my collection of, I have 6 elements. I have 3 elements in each array. Now let's see the indexing and slicing now in each of them. In 1D array, suppose I want to access an element from a 1D element, one element, I can directly pass through an index like array. This is the name, right? Suppose I want this element 3. Here also it starts from 0 indexing, like 0, 1, 2, 3. So I want the second element, so which is array of 2, which gives my third, 3 as my element. Now, similarly, I can use the slicing, like I start from 0, 1, 2, 3, right? But in slicing, 3 is not considered. You'll start, this is a starting index, and this you're going to exclude the last index, which means you go the before index, which means from 0, 1, 2. This, which means this is the starting. This will be not the ending. The before one will be the ending. So that's it, slicing. You've been knowing in the list maybe. Now for 2D arrays, the point is it's collection of 1D arrays, right? So this whole part will be your 1D. This another part is also in 1D. So and if you want to access this, first you have to enter into the 1D array. So for that, if I want an element called like 4 here, then I have to go for the first 1D array. So this is of my 0 index. Like this is my 0 index. This whole part is my 0 index, and this whole part is my 1D array, one index. So now for this I'm going for the I'm giving 0. So I entered into the first index. Now I want an element called 4. Now I've given 3, which means 0, 1, 2, 3. Actually start from 0, right? So I got 4 here. Similarly, if you want an array from here, like I want an element from here, like I want 9 here, you'll give 1. You'll give 1, which means now you went to the second part of the one-dimensional array. Now you want the third element. I've choose the 9. Similarly, for 3D arrays, you'll be taking 3, and that's because it's a three-dimensional, right? First of all, I need to go into 2-dimensional. Then I have to go to the 1-dimensional. Then I have to take the element 1. Like suppose this is my 0. Like I have put, first of all, I have to go for the 0 dimension for the second index, like the second 2D array. Then I have to go for the 0 of 1D array. Then I want element called 2, which is in the 1 index. So I got 2 here. So next I'm going to talk about the data types and hash type function. So this is basically a 1D array. I have taken 2 1D array. It can be not only integer. I can take even float values. So I have 2 arrays. One array consists of integer elements, and second array consists of float values. Now I want to know the data type of that. So I can use simply a built-in function called dtype, which helps me to know the data type of the particular list. So it's giving int 64. So this is one thing you can see difference from the list, or sometimes like it's called 64, which means it's 64 bit. It depends upon the configuration of the system as well. Okay. And similarly, this is a float which consists of 3 values, right? So it's a float type. So it's a float 64, which is float of 64 bit second array. And now, suppose if you want to change one array type to another, like I have a float type here. Now I want to change this array type from float to integer. I can simply use dtype is equal to I. And not only I, which means I represents as integer. You can also use like the strings, like you can use Unicode strings. I can use float, boolean. These all there are a lot of things you can see. You can see in the documentation, and this gives me, like if you print the array 3, so you can see here it's a float type 1.3, 4.5, 6.7. Now I change this to integer. So what happens? What integer does? It neglects the float, the decimal values. So this 0.3 is gone. I got 1, 4, and 6 in this manner. Like next, you can also use this data type to assign the bytes to it. But point is, one thing you have to remember is a byte consists of 8 bits, right? So if I give 4, now it's 8 4s is 32. So I can change it to 4 or 8, right? it can be of 32-bit or it can be 64-bit, like if according to configuration of the system. But you cannot give like I32, I42. That thing you have to notice. And then, so what I've done, I printed that array for the D type. I got 32-bit. Initially it's 64. Now I changed it bytes to 4, which became 32-bit. Now, we can also use type function to change a array data type. Then what's the difference between data type and type? Type is a method of array. We will use with array function, with array method. This is not a method, it's an optional argument. Okay, you can also change it from array type, from integer to float. Now, this concept, shape and reshape, is most important when you're working with numpys. That's because this you can relate this with when machine learning, because they will be using more and more with shape and reshape. So let's consider this. We have a two-dimensional array of consists of two one-dimensionals. Now have given one built-in function called shape. So what it's going to return? It's giving 2, 4. That's because these are having 2 dimensions, each containing 4 elements. So I got an shape called 2, 4. If I have 3 and each consists of 4 elements, then I'll have 3, 4. That's what shape returns. And reshape is a choice, like a chance. If you have if you have a chance like 4, 2, that means I can change it to 4 rows and 2 columns, like you can see here, 2, 3, 4, 6. If you have a chance, you can change like the way you can. But if there is a no chance, like if I give like 4, 4, but I cannot give like 4 rows and 4 elements in each, right? If you have a chance, like you can change the shape of it, you can do that using reshape. Like I have changed from 2, 4 to 4, 2, like 4 rows, 2 columns. Then this is called the flattening. Suppose you have a 2-dimensional and you want make everything into 1 dimension. Then simply if you pass -1, means you can change from 2-dimensional to 1-dimensional. I can see this all elements measuring to a single 1 dimension. If it is a 3-dimension and if I give -1, then all these elements will go into a 2-dimension. Okay, let's again jump into the next data type. Okay. So next concept is matplot library. So this was basically matplot library was invented by John D. Hunter, and it's basically a graphical representation of your data. So what is this? So until now you have learned how to create a data, but if you want to visualize the data, or if you want to show that in a graphical manner, you use matplot library. And it's also an open source project which is free to use. Next. So why do we need matplot library? And that's because visualization. You can see I'm going to show this, why this visualization I'm emphasizing more and more. That's because you can see a lot of cool features you can do with matplot library. And another thing is this graphical user interface toolkits like in Python, like Thinker, SciPy also make use of matplot library. And not only that, the one more library called Seaborn, which is also another data visualization library. It's completely based on based on matplot library. That's because you can call Seaborn as an advanced version of matplot library. Okay, so let's see the cool features of that as well. Okay, so before saying what I'm going to say, let's say something about matplot library. So when you consider a movie and you're reading something, which is better? It's better to see a movie, right? From movie you can learn it more. In that manner, when you have a data in unordered form, it's more difficult to understand. You cannot analyze the data, cannot predict the data. But if you have a data in this format, like you can see some data which you can predict and work on it. That's what matplot library. So by using NumPy, and you have created some data, and using that data, now you can visualize that by presenting them plotting them in terms of graph. So in matplot library also, there is another package called PyPlot, which is a submodule of matplot library, and it has a lot of functions and features you can work on with. And also you can give your own alias names as well. In industry, you'll be using more and more PLT. So like NumPy, using NumPy, what you'll do, you'll create two arrays of each one dimensional. Now, what is this plot? This plot is basically called as line plot. Means I'm drawing a plot. And now I'm comparing both array and array one, and I'm drawing a plot which is of one dimensional, is two one dimensional. I'm drawing a graph, and this is considered as x1, x1, x2, x3, and y1, y2, y3. In that manner, it's been drawn. They can see 0, 3, next 2, 4, 2, 5, and 4, 7. These things, all this x-axis, y-axis scale will be taken care by the matplotlib library. That means you don't, that no need of take or we don't need to take care of that. And the next thing is, you can also give some points to that. Like you can give some this is called as markers. Like you can give some mark points to that. So before you have seen only the line, right? So you can also give some points here, like here, here, here. That's what here. That's what you can see here. Suppose you have two arrays, each consists of 5 elements. Now I'm drawing a plot between them. Okay, you have got a line like this. So now I want to give some points for that. Now by giving this marker in this plot, comma, this is called O. You can give some plots to them. They can give some points to them. And it's not only O, there are a lot of markers. They can give some star, you can dot, plus, and you can see a lot of them in the Matplotlib library documentation. Okay, so then this all, then next comes the MS, MEC, and MFC. These are all the other optional arguments you can give or not, but just for the knowing purpose, you're learning this. Suppose you can, the first comment I want to discuss is here, the B. Like in the slicing manner, you have given B here, right? So this represents B, means the blue. I want this line. You can see a color here, orange and blue, right? These are the default colors while you're working with Matplotlib library. But if you want to change the color, change the color of the line from blue to, like suppose the dark blue or some this color, I can use the color which I want. It's not only you can use B, you can use green, like G. For red, you can use R. In that manner, you have a lot of colors. Okay. So what I've done is I have pointed O. So I have got in this manner plots. Now I've given B to get blue in color. Now this MS is what called marker size. So you can see here in the before image, because the image is very small, right? If you want to see that in a larger image, I can increase the size. That's called marker size. The marker point, I want to increase the size. This is MS equal 18. So from this, I have increased the size and I have got 5 points in larger images. Then I have the MEC, which stands for the marker edge color, which means you can see here, I have no edge colors, right? I can give some color to that. These colors I have taken as red. So all the edge colors for the marker. So basically this is a marker. I have increased the size to 18. I have given the edge colors as red. And finally, MFC is a face color. As I said before, by default it has taken as orange, but you can give it as green, like I've given green. That's your wish. So these are some of the optional arguments in the plot. So basically, you have a lot of plots, like you have scatter plot, line plot, bar plot, histogram, box plot, a lot of them. Among them, this plot is called, if you give just a plot, it's called a line plot. You can draw like normal lines, okay? And these are the optional arguments like MS, MEC, MFC, and this B, the color. Next, you can also change the type of the line, like using the line style. Another optional argument you can use, which is the line style. Suppose I want in dashed format. Until now you've seen in this line format, right? This is called a solid line, as normal solid lines. But if you want in dashed format, then you can pass the LS. You can use the shortcut called LS, or you can also type the string name like in line style. And you can pass the value as dashed. So you can have the optional arguments, you can give dotted, or you can also give solid, or also you can pass the sign. You can remove this, and also you can give dot hyphen, like this colon. It also works. So you have multiple choices. You can give your lines. They can directly type this, or you can give the shortcut as ls. You can give the symbol, or you can also type the its name as well. Anything works. And you can change the shape of the line. Like you can see, I have got a dotted lines, and now I'm going to talk about the subplot. What is the subplot? So what is subplot is, so you can see a single image, right? You can see in the single picture, you can see a single image. But what if I want in a single image two subplots? That's what here. If I remove this, these two pictures will be merged into in one picture. Then you cannot analyze what is happening there. So by using subplots means I can divide two subplots, like this is of one plot, this is of another plot. And in subplots, I have three parameters. One is row, the another is column, and the other one is the which array I want to choose. Okay. So first I'm choosing the array tree. So this array I'm choosing, which is I'm going to choose as one. This one priority I'm giving to first one. Now the ls I've given is dash. Now what is this title? So I want to give some name to that. If you do not give a title, I'm not able to understand what is happening there, right? So but for better understanding, this is another method I can use called title to give the title to that. So by these three operations, I have created one subplot called non-inverted with title, and with as for this array, like you can see, this is 13, the 14 is here, and 15, then 23 and 22. This is what I have drawn here using array 3, and in dashed format with title non-inverted. Similarly, I have done for the second array. So 2 rows, 2 columns, and the second one I have given priority to for the second array, for this one array 2. So I have plotted in a line plot. This is the line plot. I have given color as red, so it turned to red. Then I've given the title as inverted, so the title is inverted. And finally, this super title. What is this? So if you want a title, like main title, see, if you consider this as main title, these are two subtitles. That's what a super title means, a main title. Like I want to give it as images. And this shows you what is happening in here. That's what basically happening here. Next, as you mentioned, we have seen until now the line plots, right? Now we are going for the scatter plots. So scatter plots are like you're presenting in dotted formats. You can show the things, you can see here what is happening here. Let me discuss what is happening here. So like before, I have taken two arrays of single dimensions, okay, of 10 elements, let's suppose. I have compared both arrays. This is the function I'm using. Earlier you have used plot. Earlier you used plot for the line plots. If you want scatter plot, you have to use scatter. And for the comparing these two, I've given array 2, array 3. And for the array which array I want for these two arrays, I want in color red. So these are the points you can see. All these all colors represents the array 2 and array 3. And then I have taken another two arrays, array 4 and array 5. I even done the same thing. I have compared array 4 and array 5 with color as green. So you can see green colors here. So by this, I can plot some of the points on arrays in the scatter plot. So another thing what I have introduced is the color bar. This is the color bar. You can see starting from the violet. Starting from the violet, it's going up to the yellow. Okay, this is the scatter plot I'm drawn here, and you can from this you can relate that it's a three-dimensional one. Like I have a x-axis, I can y-axis, and from this color bar, it's a three-dimensional one. Okay. Next comes the bar plot. Like now we have talked about line plot, scatter plot. Now the third one is the bar plot. So until now you have taken integers, you have taken float. Now let's take a list of strings. So let's take 5 subjects like maths, English, science, social, and Sanskrit of one array. The second array consists of 5 integers. Okay, the marks of each subject. Suppose I have given a title as marks. So this is the thing I have created. Now what I want to do is I want to plot it in bar. So what I'm going to do is, first of all, I'm taking this H to understand. 1 minute. I'm going to execute this. This is what the default version is going to give you in the vertical format. Like array 2 and array 3. I'm comparing both array 2 and array 3, and I'm giving color as red. So you can see I've given the colors in red format we have the x-axis, y-axis, the subjects for each subject, and the scores. We have for the particular scores. You can see them. And the point is, if you want to change the like from the vertical to like horizontal, you can simply give h here, which means converting from vertical to horizontal. You can simply give a bar h, which means plotting bar in horizontally. Okay, that's it from bar plot. And you can also do, you can increase, you can also give the width. And the point to remember is the default width is 0.8. But if you increase more than 0.8, all these things will be merged into one kind. So be care of that. So default width will of 0.8. You can increase the width as well. Next, the histogram. So what is this basically histogram? Histogram is basically a frequency distribution plotter. So what I've done here is starting to panic here. So if I can also take in this panel only like an array of 5 elements of that, but histogram, if you take more number of values, you can have better results. So for that, what I've done using NumPy, I have imported another package called random. From random, I have imported another function called normal. So from that, what I'm generating is I'll take 170 different random values, each of 10 standard deviation, and I'm concentrating it to 17. That's what I'm doing. So I'll get different 170 values running on, and like you can have even negative values as well. That's what is giving negative values as well. Now you can see some are increasing, some are decreasing, some are increasing. It's happening. That's what actually histogram. Suppose you have 5 or 10 unique values, it will increasing. If the same value duplicates, then it been increasing to the particular value. That's what an histogram says. The same thing what I've done. So here you'll use hist. Like I've used plot for the line plot, scatter for scatter plot, bar for bar plot, and hist, which is for the histogram. And a given color. This is obviously understood. And finally, this is called pie charts. Similarly, like to the other four, the fifth one is the pie charts. You can take an array of, I've taken a one-dimensional array, and this is what I'm going to introduce other part in pie. Here you're going to give the pie, like the part, scatter, here you're going to give as pie. And you're going to compare that with array 2, and this is what I want to give. Suppose if I do not give this one, this is another optional argument called labels. If you do not give this part and remove this, then you'll get only this pie chart without labels. So in order to get the labels is the optional argument. I've taken an array of 5 names related to the arrays. Like I have 5 values, so I have 5 strings. So 1 represents food, 2 represents entertainment, 3 represents savings, 4 represents others, and 5 represents rent. So I passed that as the labels, so that I got these names as here. Then I use another built-in function called legend, which actually gives you the what is happening, the colors, what are the things. You can easily identify them this legend, give details of that. And I given the title for the legend as my savings. So let's jump into the PPT. So next concept, which is pandas. It was basically invented by Wes MC Kenny. So it's basically a data manipulation tool. So up to now, what you have seen, you have known how to create a data, how to visualize the data, and how to analyze the data. But if you want to manipulate the data, or if you want to modify the data, then Panda is the better choice. So it's a very high-level data manipulation tool, and you know that if someone invented something, then the other will be try to optimize that. That's what is happening here. You can build on, it was actually built on top of NumPy, providing high performance. That's because already NumPy have created its library and its data. But if you want more performance, like more data like it have introduced the data manipulation, data cleaning, and fast analysis, we have introduced the pandas, and it's also an open source library, and it's easy to use data analysis tool. Next, so why do we need these pandas? So That's because it has a lot of useful functions. Like there are a lot of things are stored in pandas. The functions which from those functions we can actually analyze and manipulate. And this manipulation will be the difference between the NumPy and the pandas. You can easily insert missing values. You can easily delete the missing values. You can pass new values. There will be no error in that. But that will be an issue in the kinds of NumPy that you will be seeing in the notebook, Google Colabs. So that is the another thing. Why should you learn pandas? It's mainly work with the tabular data. So while you consider NumPy, it works with numerical data. So what is that? In numerical data, you'll be having the numericals like integer floats. Well, in tabular data, you can have in a tabular format, like in multi-dimensional arrays, like you have rows and columns. There will be having more very important keys data structure called the data frames. And this data frames is the thing you'll be relating more and more in machine learning. And this data frames is the main reason we'll be choosing pandas as our we'll choose pandas while you're running in the library for the data science or data scientists as well. Okay, now let's jump into the collab. Okay, so this is also simple. Like the NumPy and Matplotlib library, you're going to import pandas, and this is your alias name. You can give whatever you want, and this is the industry preferred one. And as for now, don't consider this. I'm going to explain this afterwards. For now, just consider import pandas and PD, and you're going to use NumPy also. So the basic method called series. So using series, like arrays, like you've done, you're going to use series to create an array. Okay, and now you want to, and up to now you know how to create an array. But if you want to change the order, like I want to change the order, you can see here the index is 0, 1, 2, 3, 4. That's what you know, right? In the arrays, you know it starts from 0, like 0, 1, 2, 3, 4. Suppose if you want to change the order of this, suppose I don't want to start from 0, I want to start it from the 1. If that is the case, like you've done in the labels in the Matplotlib library, you'll take in another array, like you give 5 values, 1, 2, 3, 4, 5, and I'm passing that as index. This is the index is the another optional argument which you works with series in the series parameter in the series function, so that I can change the order of this. So now, as you see in the before one, the output, the data type is of int 64, and it consists of, it starts from 0 up to 4. Now, once I change the order of this, you can see the order is changed from starting from 1, 1, 2, 3, 4, 5. Next, you can also take as index as strings. See, you can have done like I have the before one. This is the default one. This is the thing I have changed from the 1, 2, 3, 4, 5. I can also do it in the strings as well. I've taken 1 closing parenthesis, 2 closing parenthesis. In that manner, I've taken an index array of strings. And using this random function, I've generated 5 random values. So basically, this is from NumPy package. Another module called random. I have inside NumPy. From that, random is another function which you'll use to generate random values. So I have generating 5 values, and the point to notice is if one value is given, which means you can generate 5 values. It's a one-dimensional. Suppose I have given 6, 4, which means you're generating a two-dimensional consists of 6 rows and 6 rows and 4 columns. Now, so using the series, now what I've done, as I said before, I've changed the order here. Now I have kept the strings and I've represented them in order like 1, 2, 3, 4, 5, the way I want. Next, here also what I've done is I've taken strings of capital letters. So let's create a neat do some of the cool operations on this. So I've created another index array A B C D E, and then I've given this order for this float values for these array elements. So you can see here, this is the array I've created: 1.2, 3.5, 6.7, 9.8, 7.0. I've given the index as A B C D E for the first array, and for the I also created another array called -3, -12 in integers, in negative numbers, and I've given a neutral number. Then I've given the order for this as small letters A, B, C, D, E. Now, what I want to do is, like in list you have done in Python, you can also use the append function here to join two lists. Or you can you can call it as two series, join two series. So you can see here the before it is capital A B C D E, now it's small A B C D E. Now I want to join both capital letters and small letters. So now you can see here I've combined both the things into a single series. This is called third series, series 1, series 2, series 3. And fourth one, suppose if you want to drop something from here, like suppose I want to drop this value of index C. Okay, I want to drop this value of index C, right, of -9.0. Simply I can pass the index C as here to drop that particular value. Okay, so you can see here I have dropped that value. This C 9.0 is not there here. So in this manner you can drop, you can append. You can also slice here as well. You can also slice here -2 here. So you can see here I have sliced it from -2 to last. So you can, this is -1, this is -2, right? So I've got only these two values, D and E. Sorry, this D and E. Next, let's see some of the operations in this pandas. So we can also do add function, subtract, multiplication. So, but the point is, the thing what I want to mention here, that the thing is here in NumPy, suppose you have 5 here, array consists of 5 elements, and I have array consists of 7 elements. Now if you want to add both them, the problem is you get an error, which says that both arrays should be of same size. But in pandas, that's not the issue. If you add two irregular sizes, then also it gives you. But in the other places which are left, suppose here you have 5 elements, and here I have 7 elements. The other 2 elements are filled as missing values. It will represent in this NaN form, which shows that it's of missing values, or it shows have no value here. Hello. Similarly, you have subtract and multiplication as well. And another thing I want to discuss here is the divide function. Why I'm emphasizing divide is, suppose if you want to divide a value like 4 by 0, you'll get an infinite value, right? That's what is showing here. Suppose like see 1 by 6, it's giving in decimal, okay? And 2 by 7, 3 by 8, and 4 by 9. Sorry, and 3 3 by 8. So if I try to do for 5 by 0, it's showing an infinite value. This is what I want to show difference in a. I want to show difference between the other ones, right? Here INF means infinite, and the other things like I don't have two values for the division, so I have two missing values. So you can also do median for the first series. I got 3.0. It's like median is like you can do the average. Like if I do the average of this, I'll get 3.0. Similarly for here, I'll get 8 as an average. If you combine all that and you take the number by the total number, you can get the average. Then similarly, the minimum and maximum, you can also do the operations. Next, this is the most important concept. Now we're going to discuss data frames. You can relate this with the machine learning, because in machine learning you're going to read a lot of CSV files, JSON files. You convert them again to the normal files. For there you will be using data frames a lot and lot. Basically, data frames is organizing your data in a frame model, like in tabular model, like you have seen in this model. So what I've done is I've taken dates. I've taken dates using the Python data pandas built-in function called date range, and I've given today as a parameter, and I pass the periods as 5. So which means from today, this is today, right? This is today. This is 11th November 21. Today is the date of this, and today time will be presented here. And starting from now, I'm going for another future 4 days, because I'm giving 5, right? 1, 2, 3, 4, 5. Now I'll get 5 periods of 5 data timestamps of like from 21 to 25. Now what I've done is, so considering these periods, now I've taken as some random values. So this 5 and this should be of equal. As I said before, If you're given two values, which means it's a two-dimensional, this represents rows and this represents columns. If I have 5 times, then I should have 5 indexes, right? So for 5 indexes, I've given 5, and for the 3 is for the columns. I've taken another column array ABC to represent that, like for the names ABC. Now I have constructed a data frame using all this data what I have created. Now I have a data range, like a dates range. Now what I'm going to do is I'm going to construct a data frame using the built-in function called pd.dataFrame, and I'm passing this data. I'll get a 5 cross 3, means all these 5 cross 3 are the random values. If you keep on executing, you can see another 5 into 3 random values generating here. So I've given the names, I've given the index as the dates, and the column says column. Now it seems to be a little bit confusing, but let's start with the basic normal one. You can also have a data from a dictionary as well. Like I created a dictionary data, like this is the key and this is the value. I have a hex as my key and this is my value, like a list. Next, I have another key called Y, and I have another list called DSC Git, like DSC GITAM. Then I have Z as key, and I have a list of float values. Now what I've done, now I have 3 columns. One column consists of integers, one column consists of strings, and one column consists of float. I want to give the indices for them. So for that, I have 6 values in each, 1, 2, 3, 4, 5, 6. See, in that manner. So I should have an index consists of 6 elements. So what I've done, I've taken an index array which consists of A, B, C, D, E. You can give your own names, and I construct the same. Now I have my data. Like above, I have a date range data. Now I created my own data, and I passed the data here and given the index as index. Now I printed the data frame. So you can see I have index A, B, C, D, E, and column names as X, Y, Z, and the values as integer, string, and float. Okay. Next. So in pandas, if you want to know the data types, you're going to give D types to know the data types. So for the X, it's of int type, right? So it's giving integer. For float in pandas, it represents as object. And for the strings, it represents as object. And for the float values, it gives a float 64. And overall, it says that it's object, which means it is universal. Like universal means it can be of anything. It can be integer, can be object, can be float, right? Next. So if you want to know only the 2 values, like this is called the head function, the built-in function in data frames, so which helps to give the top rows. Head means like top, right, and tail means the bottom. This head function helps you to give the top rows. If you do not mention any parameter like 2, it by default give you the top 5 rows. Let me show you. Yeah, if you do not pass any value, then it by default gives you the top 5 rows. But if you want especially the top 2, I can give the parameter as I show you. You can give 2, 3, 4 as you wish, like depending on your data. Like I have head, I can have my tail as well. Suppose I want my last row. If I give my 1, I can get my last row. You can see the F row. Similarly, I have my another built-in functions like index, columns, and values. But point to remember is these are not the calling functions. Like I have a parenthesis here. I'm not going to have a parenthesis here, like in index, columns, and values. I think you have to notice here. So this function helps me to give the indices. Like what are the indices? A, B, C, D, E, and F, right? So these are my indices. It's giving my output as A, B, C, D, F. And the output for my columns are my X, Y, Z. And what are the values? These are the values. So you can easily extract them and you can work on them. Then we have the describe. This is also one of the important concepts. We are working with data frames. It gives you the details about, like you have a doubt, right? I have X, Y, Z, right? But it's only taking X and Z. and that's because it only concentrates by default as numerical values, like only integers and floats. You don't take the strings as by default. If you want every data to include, then you can use this. Uh, you can simply pass that here. You can simply pass include is equal all, which means all the data I want. Now you can see all my 3 rows has been included, and it have some missing values as well. So what this describe function do is, by considering the data you have, it'll give some description, like it can give some, like it say about the count, uniqueness, the top, the frequency, mean, standard, minimum. Don't need to again do for the mean, standard, minimum. It by default going to describe all those things. Next, if you want to transpose your data frame from the horizontal to vertical, vertical to horizontal, simply by giving t here, you can simply transpose it. Like suppose I have in this format, right? This is my in this format. Suppose I want to transpose this, simply by giving dot t, I can transpose that. And suppose you want a particular row, you can sort it by sort values by equal to by equal to y. So only I want this, I want to sort this like in alphabetical manner. Then I can do it in C, D, G. You can see here, it is in unsorted manner. Now I want to sort that. You can see it's been sorted in order, right? C, D, G, I, S, T. And what I've done, I've given it again in transpose, so that you can compare both them easily. And the point to remember is, when this is changing, even index also will change this, right? So actually it start from A, B, C, D, but index also change here, right? So C comes here, then A comes, then B. That's also you have to think here. Next, this one of the another important concepts is iLoc, which is integer location. It's like slicing. You're using data frames. So what I want to do is, I'm pass 1 and 3, like slicing, starting from 1 index, excluding third index up to 2. So I'm getting only B and C as my rows, right? So I'm getting this. That's what iLoc. iLoc stands for integer location. So by giving 1 and 3, you can see here, I'm getting a slice of this big cake. Consider this is a big cake. These two parts is of a small cake. Okay. Then we have another important function called eastern. See, you have a data right here. It checks for the null values, like before, like I'll show you, like this. Is there any null values here? We'll check for that. So as of now, I have no null values. So it's showing all are as false. As I have only integers, strings, and floats, so it's showing all as false. Suppose if I run here, like if suppose I run here, I'll get all as trues here at this position, because there is a null here. That's what null function says. Next comes the lock. So people will be confused with iLoc and lock. iLoc is basically as integer location, but lock is you'll be assigning something, like you're going to lock something. See here, suppose I want to give 13.0. It's actually C is not present, but I'm going to explain you. See here, D will be your index, and the first part will be your index value, and the second part will be the column value. But in my column, actually I have X, Y, Z. I don't have C. But if you pass an unknown value, it's going to create another column, and it's going to assign all the null values or missing values, and it's going to give us 13.0 at that position. So at D index, at C column, it's going to assign something 13.0. And once this is locked, you're not able to change again that. Okay. So next comes the filna, which means if you, as I said before, this is a Python pandas. You can manipulate your data. You have missing values, right? It seems to be so odd. Suppose so I want to insert some values here. So this function helps me to insert some values into that. Simply by giving this fill now function and pass the value, it's going to fill in that missing values. Wherever the missing values are there, it's going to fill that. That's why it's called fill now. And the other one is the drop now, which means if consider this one, So if there are any missing values, drop every row there. That's what its function says. Only one D is there, which is of no missing values, right? The other rows consists of some of the missing values. And what is going, so it's going to give only one row, which consists of no missing values. And finally, this is the things I want to discuss you. Uh, like you can convert your data frame to CSV file. And now I want to discuss you with the import statement. See, earlier I told you that I'm going to discuss here, right? So once you create a CSV file, if you want to see what is happening there, so you can simply use from Google Colabs and import files. From Google to Colab, you can input files, and so that you can download the CSV files. So for that, I have imported that one. For the purpose of this one, I've imported that. And using that files, I've downloaded the CSV files. What are the CSV stands for? Stands for comma separated values. So if I want to change the data frame to a comma separated values, simply by giving two CSV, I can convert it from a data frame to a CSV file. And I'm giving them a name, the demo.csv. And I have downloaded that file. And once that is done, I have read that file using pandas pd.readcsv. Again, if I want to read that, and if I printed that, this is the thing that was there here. It's not only CSV files. You can do like two JSON, you can do two Excel, and you can read CSV, read Excel, read JSON. In that manner, you can use this, and this concept will comes into handy when you're going to machine learning more and more. Okay. Okay, that's it, guys. Your developer students clubs, being GITAM Team to University. And if you have any queries, so now it's a Q&A section. Let's discuss now in a Q&A section. Shoot out your queries in the chat box.
Guys, these notebooks will be shared to you on your mail, so no need to worry about the code. We'll share it by tomorrow. And one word of advice. So now you have just learned the basics of NumPy, Pandas, and Matplotlib. These three libraries are very important when it comes to data science. So just go through the documentation. Just go to Google, write NumPy documentation, and you'll get a whole list of functions that particular library has. So here we just showed you 5 to 10 functions. It has actually hundreds of functions. And if you have any doubts, you can put it in the chat box or you can unmute and speak. So
So
right now we are.
this is the documentation. Like Session told, you can just type NumPy documentation and you can go to this portal and you can see. We have discussed only one or two. There are lot and more here. You can see a lot of things here. Like zeros are there, ones are there. Like I've discussed only the important topics. You can see a lot and more here. You can do the sorting, all these topics here. Similarly, you have for pandas and for the matplotlib library. You can explore that. Okay. Over to you.
Yeah, thank you, Sunil. So we got a question, how to change the axis of any plot from Manish. So um, there are actually, see, every function has a bunch of arguments. So I'll just tell you the general overview. So here you can see there's matplotlib.pyplot, which we imported as PLT, right? So you can write plt.xlim and plt.ilim. And then inside that you have arguments. So you want to change the values, you want to change the names. That's why I told you, just go through the documentation. This question will be answered there. So just to tell you, we have plt.xlim and .ylim. There are two functions. And inside that you have arguments. And those arguments, when you see, you have arguments such as new ymin, new xmin, new xmin, new ymin, new xmax, and new ymax. And there you can change the axis as well of the plot. So that's why I told you, just go through the documentation and all such questions will be answered. So anything else, guys? You can put it in the chat box, you can unmute yourselves. So I think no more doubts then. So that's cool. If you have any other doubts, you can also join us at our Discord server, and we will be available there 24/7. You can bring all your questions there. So if there are no more questions, we can just wrap up today's session. Okay, cool. Then I don't think any questions are there. So thank you so much, guys, for joining us. That's it for today.
Yeah, thank you,
Thank you.
Sasant, and thank you, Sunil, for a wonderful DS session. I hope everyone who have joined have taken something bad in DS. If not, at least all the visualization stuff was amazing. Thank you. And yeah, that's all for today. If any questions, you can just yeah. Sunil, can you just put that last slide where we have the links for DSC GITAM?
Yeah.
Yeah, so we are so all our social media profiles are available in this link. You guys can come join us there. The ML and DS team will be always available to you in the Discord. You can ask them any doubts you have. And yeah, basically that's all. Thank you once again for joining us in the Saturday evening session.
Thank you very much, guys.
Yes, you know you can stop with